hypothalamus artificial intelligence, Cisneria engineering, and Gurobi optimization. Hypothalamus artificial intelligence, Cisneria engineering and Gurobi optimization have agreed on a technology alliance to jointly provide services to the special transport sectors, based on highly complex mathematical models. The technological capabilities of the three companies, in artificial intelligence and mathematical programming, make them ideal partners to face the multiple challenges that exist in advanced analytics applied to the transport sector. Due to the experience of the two companies, this alliance is particularly strong for the optimization of special transport systems such as the aviation industry, planning and operation of ports, and rail systems. The Sabre story history, the making of operations research magic at American Airlines. It is the result of the success of operations research in the industrial environment. If necessity is the mother of invention, then deregulation of the airline market is the father, and revenue management, also known as yield management, is the couple's golden child. The relationship between American, Sabre and operations research is as robust and complex as the models and problems they tackle every day, but most of all, it's a richly rewarding relationship for all concerned. AMR, the parent of American Airlines, and step-parent of Sabre Decision Technologies, provided a nourishing home in which soared to unprecedented heights in terms of impact on American, on the entire airline industry, and on a good chunk of the rest of the corporate world. Fueled by constantly improving forecasting and optimization models fed by more and better data, each new generation produced in excess of $100 million in incremental profitability over its predecessor. By 1998, Cook estimates the revenue management system at American Airlines was generating nearly $1 billion in annual incremental revenue. To put that figure into perspective, consider that the airline's total operating profit didn't approach $1 billion until 1997. Today, virtually every airline in the world employs some sort of revenue management system. The concept is also hard at work throughout the cruise, hotel and car rental industries, and wherever else you find perishable, limited capacity. The early victory. In 1985, People Express, an everyday low-price airline, was named the fastest-growing company in America. By September 1986, however, People Express was dead. What changed? For one thing, American Airlines implemented a new version of revenue management. In 1992, AMR estimated that performance management has generated $1.4 billion in incremental revenue over the past 3 years, by creating a pricing structure that responds to demand on a flight-by-flight basis. On the other hand, Donald Burr, founder and CEO of People Express, believes that major carriers' use of sophisticated computer programs to immediately match undercut his prices ultimately killed People Express. Epilogue. The firms with the best revenue management will prosper and grow, the remainder will struggle to survive by restricting themselves to local or niche markets. What you don't know about revenue management could kill you. Now, airline revenue management. Mathematical modeling. Revenue management is the application of disciplined tactics that predict consumer behavior at the micro-market level and optimize product availability and price to maximize revenue growth. To optimize prices, the starting point is pricing in microeconomics. In a perfect market, the equilibrium point of the market is determined by the point where the functions of aggregate demand and aggregate supply intersect. Quantities greater than Q cannot be produced because they would be unprofitable for the producer. The social surplus is equal to the surplus of the consumer, plus the surplus of the producer. The break-even point maximizes the social surplus. In an imperfect market, such as the airline oligopoly, the producer can segment the market and set differential prices in each segment, considering the consumer's willingness to pay. The segments can be the types of chairs offered, through different classes, VIP, executive, economic, and tourist. If the airline knows correctly the function of demand, that is, how the elasticity of demand with respect to price varies, it can maximize its surplus by optimally defining the number of segments and the number of seats and fares for each segment. Traditionally, the airline revenue management has been based in two types: prices. Static pricing, rates are generally the same for a particular route, regardless of the time of day, day of the week, or season. Dynamic prices, rates change frequently along predefined prices based on time of day, week, seasonality, and other factors. In the near future, it may be now, revenue management in the airline industry will be determined by AI-related technologies, which make it possible to capture and analyze big data in real time, and make automated pricing decisions. This process can be called continuous pricing. As IATA explains, continuous pricing is an additional enabler of supply optimization, as the airline can greatly refine the price offered compared to traditional options, which are inflexible. A much more dynamic market, including the world of e-commerce, in which prices can be adjusted online, has brought flexibility to pricing. New and increasingly sophisticated mathematical algorithms have made it possible to optimize prices, balancing a much more dynamic market, in which prices can be adjusted online. This has brought flexibility to pricing. Then, it is possible to optimize prices in order to balance the likelihood of winning business, with maximum contribution to profit. As a result, revenue management has become pricing and revenue mathematical optimization, using predictive advanced analytics as input. Maximize revenue can be broken down into three main activities: pricing strategy, seat inventory management, and selling strategy. Another problem is overbooking. Considering the behavior of customers, it is known that in the end there will be an uncertain number of no-shows. If sales are limited to the capacity of the aircraft, the no-shows will cause the plane to travel with unoccupied positions, which is equivalent to a loss of demand. Therefore, the optimal decision implies that more tickets must be sold than the available seats, trying that on the day of the trip the no-shows, and last-minute cancellations, are in balance with overbooking, and the plane leaves with full capacity. This is a mathematical problem based on predictive analytics, aimed at predicting customer behavior, and the optimal allocation of overbooking. Optimal airplane seat layout. Each airplane has a limited space which can be allocated to first class, business class and economy seats and others. Some factors will influence the decisions regarding the optimal seat layout as follows. The ticket price for each seating category is different, the number of demand for each seating category is subject to uncertainty, space occupied by each seat type, for example, first-class seats will need more space compared to economy seats. This is a typical problem of revenue management, since it is not evident what is the decision that maximizes income, this is, which it is the number of positions to assign to each class. It ends up being related in the number and type of aircraft, the routes and the aircraft to be used, the type of passenger to be transported, and the price, which can be dynamic, change as the date of travel approaches. The price can increase if there is undersupply in the market, and it must go down if there is oversupply. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.